Okay, students, now we start the next topic, acceleration. Now you all know in a car or any vehicle, there is an accelerator pedal and a brake pedal. And you all know the function. When we want to increase the rate of the speed or the velocity of a car, we press the accelerator. And if we want to slow the vehicle down, we press on the brake. So we will see how this is related to motion. When we say acceleration, it is the rate of change of velocity or the change of velocity in a unit time. So if we define acceleration first, acceleration is the rate of change of velocity, or we can say change, or the second definition or the other definition, change of velocity in a unit time. So this is the definition. If we put it into the equation form, acceleration is equal to change of velocity we said in a time, so therefore we divide change of velocity by time. So from this, if we find the unit for acceleration, velocity is given in meters per second and time is given in seconds. So if we look at this, meter second minus 1 divided by second, that will become meter second minus 2. So the unit of acceleration will be meter per second squared or meter second minus 2. The same thing, change of velocity, if we are to calculate, always remember will be the final velocity minus the initial velocity. So therefore, we can write another equation or rewrite this equation as final velocity minus initial velocity divided by time. So this will be the equation for acceleration. Now we will see how to calculate acceleration. If we use the data given here, the following table shows the manner in which the velocity of a body that traveled along a straight line varied with time. So here we talk about the variation of velocity and it has to be in a straight line. So time is given to you, velocity is given to you. You can see the symbol V and the units given. And as usual, it starts with the initial point, 0, 0 values, 0 seconds, 0 velocity. And with time, the time changes by 1 second and the velocity changes gradually. If you look at the value, just quantitatively, you can assess the values 2, 4, 6, 8, 10, 12. So you can see that the difference is by 2. So you can get an idea as to what is happening here. Then do the calculation. So calculate the acceleration for the motion described in the above table. So as I said, acceleration is change of velocity divided by time. So here also we can calculate the change of velocity, that is acceleration, for different time intervals. If we calculate for the first second, you will get the acceleration. We use the symbol A. Acceleration will be change of velocity. Final 2 minus 0, the unit is meters per second, divided by time 1 second. So that will be equal to 2 meters per second square. At the end of 2 seconds, acceleration will be 4 minus 2 meters per second divided by 1 second again. That is also going to be 2 meters per second square. Similarly, you can continue calculating. We will do one more calculation. For the third second, again you can see final velocity 6 and initial velocity 4 meters per second divided by 1 second. The acceleration will be meters per second square. So here you can see all the values have the same magnitude, 2 meters per second square. And since it says in a straight line, it is in the same direction. So the magnitude hasn't changed, the direction also has not changed. And we know that acceleration, since it has a magnitude and a direction, it is a vector quantity. And since both the magnitude and direction do not change, we call this as uniform acceleration. When you have the same value and the direction, it is known as uniform acceleration. So this is another example where there is a change in velocity. We saw what acceleration is, what uniform acceleration is. This is a different instance. Here you can see at the beginning of the travel itself, the object is moving with a velocity of 12 meters per second. So here you can see, suppose that a body moving in a straight line had an initial velocity. There is a value for initial velocity and that is 12 meters per second, and that later varied with time as shown in the table above. So calculate the acceleration of the body. So here again we use the same equation. Acceleration is equal to change in velocity with time, rate of change of velocity. So here as you can see, the object is already moving with 12 meters per second. So during the first second. You can see the acceleration. Final velocity is 9 minus initial velocity 12 meters per second divided by time 1 second. If we calculate this, you will get the value as minus 3 over 1, that is minus 3 meters per second square. We get a negative value for the acceleration. Since this is a vector quantity, the negative means either opposite direction or decrease. So here it is the decrease in velocity. As you can see, from 12, the velocity has decreased to 9 meter per second. This is known as deceleration of the object. Therefore, we rewrite this as deceleration equals, and remember students, when you write deceleration, you should not use the negative value. We write it as 3 meters per second squared. So, when acceleration is a negative value, that is called deceleration. And we rewrite it as deceleration equals 3 meters per second square. I hope you understood this. So, if you look at the displacement, this can be calculated in a different way when the object is moving with uniform acceleration. So, these two calculations will be done only for an object moving with uniform acceleration. Object moving with, you have to remember, uniform acceleration. Because if the object moves with uniform velocity, we directly multiply the velocity by time and calculate displacement. At the same time, if the object moves with different accelerations, you cannot use this equation. So keep in mind students, if the object is traveling with uniform acceleration, we use this equation where we calculate the displacement using mean velocity into time. When we say mean velocity, that is the average velocity. Here you can say if the object starts from rest, initial velocity will be 0 and let's say accelerates at the rate of 2 meters per second. So every second the velocity will increase by 2 meters per second. So it is uniform. Therefore, we take the final velocity and to find the average value, we divide it by 2. So, as an example, if we look at this question, a body that starts from rest, so you know the velocity is 0, is subjected to uniform acceleration for 6 seconds, after which it acquires a velocity of 12 meters per second. What is the displacement of the body during this time interval? So here you know the acceleration is uniform, the time is 6 seconds and the velocities are initial 0, final 12 meters per second. So first we calculate the mean velocity. Is initial velocity plus final velocity divided by 2. That is 0 plus 12 divided by 2. That is equal to 6 meters per second. That is the mean velocity of the object when it is traveling with uniform acceleration. So then if we calculate the displacement will be equal to mean velocity into time. So here you can see we already have the value for mean velocity 6 meters per second, and the time we know from the question 6 seconds. So 6 into 6, it's going to be 36. To find the unit, the second minus 1 and second will get cancelled off. You will end up with the unit meters. So that is the displacement of this object that moved with uniform acceleration. Another example, a body starting from rest accelerates for 4 seconds and acquires a velocity of 12 meters per second. Thereafter, it moves at a constant velocity of 12 meters per second. So here it is constant velocity for 4 seconds and ultimately comes to rest after 2 seconds. So as you can see, the object has 3 types of movement included here. Initially it is accelerating for 4 seconds, then moving with constant velocity and then decelerating. So the first question is, calculate the acceleration during the first 4 seconds. So acceleration, as you all know, acceleration is equal to change of velocity divided by time. So here it started from rest and accelerated for 4 seconds and finally 12 meters per second. You all know it is final minus initial. So final is 12 meters per second. Initial is 0 divided by time is 4 seconds. So that will be equal to 12 meters per second divided by 4 seconds. The acceleration will be 3 meters per second square. Find the deceleration during the last 2 seconds. So here you can see from 12 meters per second, again the object came to rest. But when you write the equation, you have to again write it as acceleration. So we write it as acceleration equal, I will use the other substituted value, final velocity, so that you will remember both the equations, minus initial velocity divided by time. So here we can see final velocity is 0 minus initial velocity 12 meters per second divided by, it is the last 2 seconds. So 2 seconds. That will be minus 12 divided by 2 meters per second square. The value will be minus 6 meters per second square. So here you can see the acceleration gets a negative value. So that means the object is decelerating. So what do we do now? How do we write this? We write it as deceleration equals, take off the minus sign, 6 meters per second square. That will be your answer. Deceleration equals 6 meters per second square. So now you have a good understanding as how acceleration and deceleration are calculated. We will go to the next part of the question. What is the displacement of the body during the first 4 seconds? If you remember, first 4 seconds, the body accelerated starting from rest. And it reached, if we check the values, it reached a velocity of 12 meters per second. So here it is acceleration. We need to calculate the displacement. So here we have to use the mean velocity. So first we'll find the mean velocity. Here of course you can write it as initial velocity plus final velocity to save space, I will write it like this, divided by 2. So that will be equal to 0 plus 12 divided by 2. That is going to be 6 meters per second. And if we calculate the displacement will be mean velocity into time. So that is equal to mean velocity 6 meters per second and time 4 seconds. So 6 into 4, 24 meter is there, but the second minus 1 and second will cancel off. So you end up with the value 24 meters. That is the displacement of the body with uniform acceleration during the first 4 seconds. Then what is the displacement of the body when it traveled with uniform velocity? Recollect your previous equation, students. When the object travels with uniform velocity, we directly multiply velocity by time to calculate displacement. So here displacement is equal to velocity into time. So the uniform velocity, as you all know, after it reached 12 meters per second, it traveled with uniform velocity. To check the time again, you can see that again for 4 seconds. So if we substitute those values here, 12 meters per second into 4 seconds. That is equal to 48 meters. Again, second minus 1 and second cancels off. You get the value as 48 meters. That is the displacement with uniform velocity. Next question. What is the displacement of the body during deceleration? As you all remember, the body was moving at a velocity of 12 meters per second. It came to rest, so the velocity becomes 0 meters per second, and this happens if we confirm the time during the last 2 seconds. So time is 2 seconds. Using these, if we calculate the displacement, again we need to calculate the mean velocity, because here again the velocity is decreasing. The object is decelerating. So mean velocity I will take the initial velocity as 12 meters per second and then final velocity 0 divided by 2. So we get the value as 12 meters per second divided by 2. Again you get the average velocity 6 meters per second. This is the average or the mean velocity. That is why it is a positive value. And here displacement is mean velocity into time. So that will be again 6 meters per second into time 2 seconds. So the value will be 12 meters. So the body has moved or displaced by 12 meters within the last 2 seconds with deceleration. What is the displacement of the body during the 10 seconds? So here they want you to calculate the displacement, that is the total displacement of the body. You all can see, children, initially the object is accelerated, then it displaced by 24 meters, then again with constant velocity it was 48 meters, and finally with deceleration it is 12 meters. So for the total displacement we will have to add up all the values. Total displacement is equal to, again to check the values, 24, 48, 24 meters plus 48 meters, and finally with deceleration 12 meters. So the total value will be 84 meters. 84 meters is the total displacement of the object. It started from rest, accelerated, then constant velocity, and finally decelerated and came to rest at the 84 meter destination. Okay, I hope you all have understood this calculation. With this in mind, we will do some more calculations. So some questions from the exercise in your textbook, exercise 2.2. The first question, if the velocity of an object increased uniformly from 0 to 12 meters per second during 6 seconds, find the acceleration of the object. So from 0 to 12 meters per second and the time duration is 6 seconds. So we will calculate the acceleration. You have to write the equation. Acceleration equals change of velocity that is final velocity minus initial velocity divided by time. So here you can see the final velocity is 12 meters per second. So 12 minus 0 meters per second. And the time is 6 seconds. So we get the answer as 12 divided by 6, that is 2 meters per second square. That is the acceleration of this object. We'll look at the next question. If the velocity of an object decreased uniformly from 16 meters per second to 4 meters per second during 4 seconds. Again here we will have to use the equation for acceleration. So rewrite the equation. Acceleration equals change of velocity divided by time. So if you substitute final velocity minus initial velocity, I will write it again just to remind you all. Final velocity minus initial velocity divided by time. So here final is 4 meters per second, initial is 16 meters per second, and the time duration is given to you 4 seconds. You will get the value as minus 12 meters per second divided by 4 seconds. That will be minus 3 meters per second square. So as you all know, if the velocity decreases, it is deceleration. So it has to be a negative acceleration. And this negative acceleration is minus 3 meters per second square. So we rewrite it as deceleration equals 3 meters per second square. The third question, starting from rest, if an object traveled with an acceleration of 0.5 meters per second squared for 10 seconds, find the velocity of the object at the end of 10 seconds. As you all know, when the body is accelerating, acceleration equals rate of change of velocity. So we use that equation to calculate the final velocity. So here again, acceleration, I will directly write the equation as final velocity minus initial velocity. Initial velocity divided by time. So here we know the value for acceleration, that is given as 0.5 meters per second square. So I substitute the value here, 0.5 meters per second square. We need to find the final velocity. I will use the symbol as V, and initial velocity we know the object started from rest. So it has to be 0. V minus 0, and the time is given to you 10 seconds. 10 seconds. Now from this equation, for convenience, what we do is we rearrange the equation. If you multiply 0.5 meters per second squared by 10 seconds, that will be equal to velocity minus 0. So here again, second minus 2, you have a second there. So they will cancel and give you second minus 1. 0.5 into 10 will be 5 meters per second. That is equal to V minus 0. So that will be the velocity V. So the final velocity of the object will be 5 meters per second. When you are answering the question, to make it more clear, we can rewrite the answer as final velocity equals 5 meters per second. Next question. The fourth one. The velocity of an object moving on a straight line was 2 meters per second at a certain instant. So here we look at a moving object. Velocity changed to 6 meters per second after accelerating for 4 seconds. Accelerating for 4 seconds. Always remember, students, when you read a question, try to pick out the information that is necessary for your calculation. Find the acceleration during the 4-second period. So here, if we use the equation for acceleration, final velocity minus initial velocity divided by time. So here we know final velocity changed to 6 meters per second. So final velocity is 6 meters per second minus the initial velocity is given as 2 meters per second. So 6 meters per second minus 2 meters per second, and the time duration you all can see 4 seconds. If we calculate 4 meters per second divided by 4 seconds will be 1 meter per second square. So the object accelerated at the rate of 1 meters per second. So students, up to now we have discussed distance displacement, speed velocity and acceleration. I hope you all have understood how to calculate these values. Starting from distance, you come to speed. Starting from displacement, you calculate velocity. Then the rate of change of velocity gives you either acceleration or deceleration. The next part of the lesson, we will put these data in graph form. So we will see how to draw different types of graphs related to motion of objects. So the first graph will be displacement time graph. From the name itself, you can identify that always the label for the y-axis will be the displacement and the label for the x-axis will be time. In a graph, you all know this line, this axis is a y-axis and the second axis is the x-axis. So here we are going to plot displacement against time. We mark the x-axis as time. You have to write the name, then use the symbol T, and within brackets you have to write the unit. Remember students, always when you label the axis, you have to have the name, the symbol and the unit within brackets. This is time. And on this axis, the y-axis, we have displacement. Displacement, we use the symbol S and the unit meters. So here when you plot the graph, it will become a displacement time graph. And we will be showing how an object displaces with time. We will look at an example with data. Now the data is given to you. You are familiar with this table. The time is given and the displacement of the object is given with time. So first we will have to label the graph. This is going to be displacement. S in meters, and the x-axis is going to be time, T in seconds. And now we will have to write the values, calibrate the two axes. So here you can see time axis, no problem. It varies from 0 to 5. As you all know, this point is called the point of origin, where the two values are usually 0 and 0. Then the x-axis, we write the values for time. 1, 2, 3, 4 seconds and 5 seconds. So here the object moves for 5 seconds. Then we mark the value for displacement. We can use 2 squares for each displacement value. We mark the value 3, then we have the value 6, the value 9, 12, and the displacement goes up to 50. So now we have marked all the points that are necessary to draw the plots. Then we mark the points or the coordinates of this graph, time versus displacement. So as you all can see, the object initially has a displacement of 0. So we mark the 0, 0 point as here. Then during the first second, it shows a displacement of 3 meters. So first second, 3 meters, we can mark the second coordinate here. Then the second displacement is 6 meters. The third second displacement is 9 meters. So here you can see 3 seconds, 9 meters. So the coordinate will be here. Then during the fourth second, the displacement has come to 12. So it will be here. And the last second, that is end of 5 seconds, displacement will be 15 meters. So now we have marked all the coordinates in the graph. Then we plot the graph. So here you just connect all the points. Starting from the 0, 0 point, we connect all the coordinates. So from here, you will get a straight line going up to 15, 5 coordinate. So 15 meters at the end of 5 seconds. This is how we plot a displacement time graph. Now not only this, the displacement time graph, as you look at it, gives you an idea as to how the object has displaced. So here, when you look at the graph, it is a line going through the point of origin and it is a straight line. So you can see the object is displacing, and since it's a straight line, it will be with uniform velocity. So we will see in the next part how to calculate information or get information from a displacement time graph. This is the same graph that we drew before. So the object started from rest at 0 seconds, 0 displacement, and at the end of 5 seconds, it reached a point where the displacement was 15 meters. And as we saw, all the coordinates are given to you here. Now in this, you can see here the graph has a straight line going through the point of origin, and you all know for a straight line we can calculate what is called a gradient. Now we will calculate the gradient of this graph. You are familiar with gradient of a graph. It is the ratio between the difference in y coordinates and difference in x coordinates. So if we write the equation for gradient, gradient is equal to difference in y coordinates divided by the difference in x coordinates. X coordinates. So when we say difference in y coordinates divided by difference in x coordinates, first we should know how to calculate the differences in coordinates. So for this, we always look at the graph and take the furthermost points. If we take this point A as our first point, the coordinates are 1 and 3. x1, y3. And you can consider this point, this point, this point. But between this and the point B, there is a big difference. So we will always use two coordinates that are far apart so that they have a larger difference between them. So we take point A and point B. If we connect the two values to calculate the difference in y is 15 and 3. That will give you this line. Whereas differences in x is from 1 to 5. That will give you this line. So when we connect all three together, you get a triangle ABC. The difference in y coordinates will be the length of this side, and the difference in x coordinate will be the length of side AC. Now we will substitute the values and calculate the gradient. As you can see here, when we say difference in y, here the value is 15, here the value is 3. So we will have to write it as 15 minus 3 divided by difference in x coordinates. You can see 5 for this point and 1 for this point. Always we subtract the lower value from the higher value. So 5 minus 1. This will be 15 minus 3, 12. 5 minus 1, 4. When you divide 12 by 4, we get the value as 3. That is the magnitude of the gradient. As you can see, this is the displacement axis, that is y-axis, and x-axis is time axis. So the units are meter and second. So we rewrite this gradient with the units 3 meters per second. So from the value, now you will know we have divided displacement by time and we have got the value for the velocity. So students, keep it in mind, the gradient of a displacement time graph will give you all the velocity of the moving object. So I will emphasize that by writing it again. The gradient is equal to velocity in a displacement time graph. So here we have got the value as 3 meters per second, and the units are also the correct units. Meters y-axis, seconds x-axis. Now we will look at another quantity that can be determined, or another information that can be obtained from these types of graphs. As you can see, this is the same graph that we used for the previous calculation. We calculated the gradient of the graph, and the gradient was equal to velocity. So remember students, the gradient of a displacement time graph will give you velocity. At the same time, by looking at the shape of the graph, you can come to this conclusion. A straight line going through the point of origin similar to this indicates that the object traveled with uniform or constant velocity. So when you get a graph like this going through the point of origin, 0, 0 point, and it is a straight line, it means the object moved with constant velocity. And that velocity can be calculated using the gradient. I hope you have understood how to draw displacement time graphs. Now we will discuss velocity time graphs. So again, as you all know, a normal graph with an x and y axis. Since this is going to be a velocity time graph, we plot time in the x-axis. So you have to label the axis, time, you have to write the symbol t and the unit seconds that is written within brackets. And on the y-axis, we have velocity. So you will have to name the axis velocity, and the symbol will be written as v and the unit will be meter per second. Then we will calibrate the axis depending on the data given to us, and we will draw the graph. So here they have given you a table that shows time with velocity. So the table below gives the variation of velocity with time for the motion of an object. So as you see, it starts with 0 point, 0 timing and 0 velocity. Then the velocity increases with time. So as I said, we have to label the axis first. The x-axis will be time, t in seconds, and the y-axis will be velocity, v meter per second, and then we will mark the values. So time starts from 0, goes up to 6. If you mark the values 1, 2, 3, 4, 5 and 6 seconds. Again, you do not have to write the unit there because we have already written it with the name of the axis. And on the y-axis, that is the velocity axis, you can see the velocity is changing by 3 units. So we can start by marking the different velocities. So from the point of origin, that is 0, 0, 3, 6, 9, 12 and 15. Then we have to mark the coordinates. So as you can see, the first coordinate is 0, 0 point of origin. The second coordinate 1 second, 3 velocity, 3 meters per second. Then we have 2 seconds, 6 meters per second velocity. 3 seconds, 9 meters per second velocity. 4 seconds, value 12. 5 seconds, value 15. And I have one more value for the 6th second, it is 18. I have to mark that on the graph. So here it will be 18 meters per second. Now as we did before, we will have to connect all the coordinates. Starting from the 0, 0 point, when you connect all the coordinates, you will get a straight line going through the point of origin. And so here you can see with time the velocity is increasing. And so from this graph we can conclude that this graph is a straight line because the increase in the velocity during each 1 second interval is the same. So here you can see each second the velocity increased by 3 units. So therefore this represents a motion with uniform or constant acceleration. So remember students, when you get a straight line going through the point of origin in a velocity time graph, it means the object is moving with uniform or constant acceleration. So this is from calculating the gradient. We will see how we will be calculating this acceleration. Here again, y'all can see the same graph, that is the velocity time graph that we drew before. And y'all can see the coordinates marked and the straight line going through the point of origin. Now we will calculate the gradient for the velocity time graph. So as we discussed before, you all know that the gradient is the difference between the y coordinates divided by the difference between the x coordinates. So if I write the equation here, difference between y coordinates divided by the difference between x coordinates. So as we did before, we will have to select two coordinates which are far apart on the graph. So we will select this coordinate and this coordinate. If we connect the two coordinates, you will get a triangle connecting the 2 points. So the difference in the y coordinate will be the difference between these 2 points. It will be the difference between these 2 points. If I name this triangle as A, B and C, one is the length of BC, that is the difference in y coordinates, and the length of AC is the difference in x coordinates. If we substitute the values in this equation, as you can see, y is 18 here and 3 there. So it will be 18 minus 3, and if you take the values of x, it's 6 here and 1 there. So 6 minus 1. 18 minus 3 is 15. 6 minus 1 is 5. We get the value as 3. 15 divided by 5, 3. Now from the axis, you all know this is velocity, this is time. So velocity divided by time, you will get the unit as ms minus 2, which is the acceleration of the object. So here gradient gives you the acceleration. If it is a positive gradient, it is acceleration. If it was a negative value, it will be deceleration. We have seen that before also. If I go back to the previous slide, here you can see this graph is a straight line because the increase in the velocity during each 1 second interval is the same. What I mentioned before, it is uniform or constant acceleration. We go back to the other slide. So here also we calculated the constant acceleration, that is 3 meters per second square. This is not the only information that we can get from a velocity time graph. Students, if you again think about the calculations, we started with displacement. When you divide displacement by time, you get velocity. When you divide velocity by time, you get acceleration. The same way, you can go back from velocity to displacement. So in the next slide, we will see how we can calculate displacement from a velocity time graph. This is another graph where the object shows a velocity that does not change with time. You can see a line parallel to the x-axis. So that means the velocity is maintained at 6 meters per second throughout the journey. So the object is under constant velocity. The object is moving with constant velocity. That is what is given to you. Velocity time graph of a body moving at a constant velocity of 6 meters per second. Now, as I said, we have the velocity here on the y-axis and the time in the x-axis. Now, we will go back and see how we calculated displacement. You can calculate the displacement using the formula you learned in the previous section. What did we do? We rearranged the equation for velocity, displacement divided by time. Thereby, we got the equation for displacement is equal to velocity into time, that is when the object is moving with uniform velocity. So here if we substitute those values, you can see that the object has moved with constant velocity 6 meters per second and time is 8 seconds. If we multiply 6 by 8, it's 48. Second minus 1 and second will cancel off. So you will get the unit as meters. 48 meters is the displacement of this object. That is using the formula we have learned before. Now if we think about how we should calculate using the graph. Now here it is velocity into time. So we need to multiply velocity by time. Velocity is the length. If you look at this shape, this is a line parallel to the x-axis. If we connect this from this point to the x-axis, you can see this is a rectangle. So this axis becomes one side, that is velocity, the other side is the time. So therefore, if we multiply this side by this side, that is the length into breadth of this rectangle, we will get the displacement. So students, we have to calculate the area of the rectangle. So we can say the area under the graph of a velocity time graph will give you the displacement. So here if I calculate area covered by the graph, will be equal to displacement. This is summarized in the next slide. So here you can see the displacement is equal to the area under the velocity time graph. I hope you have understood this calculation. When we plot a velocity time graph, we calculate the gradient, we get the acceleration, and when we calculate the area under the graph, we get the displacement. So there are two information that we can obtain from a velocity time graph. So here another velocity time graph is given to you. A body starting from rest acquires a velocity of 12 meters per second after moving at a constant acceleration for 4 seconds. You can see the velocity time graph. So initially it is at rest and finally at the end of 4 seconds you can see the velocity has come to this point, 12 meters per second. Okay, so from this we can calculate the acceleration of the graph. So that is the gradient of the graph. Acceleration will be equal to the gradient of the graph. So by now you all know to calculate the gradient we take 2 points that are far apart. So here of course we can use this point and this point where we have 12 and 0, 4 and 0 as the x coordinates and the y coordinates. So first we have the y coordinates 12 minus 0 and the x coordinates 4 minus 0. So we will get the value as 3 meters per second squared. That will be the gradient which is equal to the acceleration. Then the second information that we can calculate is the area under the curve. That has already been shaded for you all. Here you can see it is a different shape. Now if we label this as A, B and C points, you can see that ABC is a triangle. So to calculate the area of a triangle, we use an equation half into base into height. So to calculate displacement, we need to calculate the area of the triangle ABC. That will be equal to half into base into height. You can see here again. Now when I calculate the area, that is half into base is from here to here, that is 4, and the perpendicular height is from here to here, that is 12. So we will get the values when you simplify as 24 meters. So from this graph we have calculated the acceleration and the displacement. So this 24 meters is equal to the displacement of the object. So from a velocity time graph, you can calculate acceleration using the gradient and displacement, the area under the curve. So summarizing this, we can say the displacement of a body moving with uniform acceleration is equal to the magnitude of the area under the velocity time graph. I hope you have understood these two calculations. with that in mind, we will do some examples. The first example is a body with an initial velocity of 8 meters per second moves under a constant deceleration. So you have to note these terms, constant deceleration, and comes to rest after 4 seconds. Plot the velocity time graph for this motion and find the displacement during 4 seconds. So now we will plot the velocity time graph. Since they have specified the initial and the final velocity and they have given us the time period, you can mark the values. The initial velocity, we can mark it here as 8 meters per second. And the final velocity at the end of 4 seconds, if this is 4 seconds, it will be 0 here. So if we plot the graph, it will start from 8 meters per second and come to 0 meters per second at the end of 4 seconds. And we will have to calculate the area under this triangle. If I mark it, it will be the area under this triangle. So here, as you all know, displacement of an object that is undergoing constant deceleration. The velocity decreases uniformly with time. Constant deceleration is equal to area of the triangle. So that is equal to half into base into height. So here the base is 4 and the height is 8. Then we will have, when we simplify this equation, 16 meters. So the displacement of the object is 16 meters. The next example, an object starting from rest acquires a velocity of 15 meters per second after moving for 6 seconds under uniform acceleration. So here again the velocity is increasing uniformly for 6 seconds and the final velocity is going to be 15 meters per second. Then the object moves with that velocity for 6 seconds. For the next 6 seconds, the object moves with the same velocity and comes to rest after decelerating for 3 seconds. So here again, there are 3 parts for the motion of this object. Initially, it is accelerating, then it is moving with constant velocity, and finally, it decelerates and comes to rest. So we will have to use a graph, plot the velocity time graph for this motion. So first, we will have to label the axis. The x-axis is time, t seconds, and y-axis is velocity, v meter per second, and then we will have to write the values. When we mark the time, initially it moves for 6 seconds, then another 6 seconds with uniform velocity, and finally the 3 seconds for deceleration. I will mark the values on the x-axis. 3, 6, 9, 12 and 15 seconds. Then for the velocity, it goes up to 15 meters per second. Again, that can be marked as 3, 6, 9, 12 and 15 meters per second. So initially it starts from rest. The object starts at rest. Then it accelerates and reaches a velocity of 15 meters per second in 6 seconds. So we will have the next point here, and thereafter moves with the same velocity for another 6 seconds. So that is until 12 seconds, and finally decelerates and comes to rest. If we connect all these values, you will get the velocity time graph, which will give you a different shape. Y'all are familiar with this shape of graphs or this particular shape. This is called a trapezium. So since the object undergoes acceleration, uniform velocity and deceleration, we get a trapezium as the velocity time graph. Now we will look at the different types of calculations related to this graph and answer the questions. Find the acceleration during the first 6 seconds. So we know initially the body accelerated starting from 0, reaching a velocity of 15 meters per second. Since we have the graph and you know that calculating the gradient of the graph will give you the acceleration of the object. So here we can say acceleration is equal to the gradient. So gradient, we calculate the difference between y coordinates divided by the difference between x coordinates. That is going to be 15, this point, and the next point will be 0 divided by 6 minus 0. That will be 15 divided by 6 equal to 2.5 meters per second square. This is the acceleration of the object. Next question, what is the displacement during these 6 seconds? As you all know, displacement is the area under the curve. Here it is the triangle. So if I write displacement equals the area of the triangle. That is half into base into height. If we substitute the values, half, base is the time, that is 6, and the height is the maximum velocity obtained by the object, that is 15 meters per second. So if we substitute half into 6 into 15, you can simplify this equation and you will get the value as 45 meters. So 45 meters is the displacement of the object with uniform acceleration. What is the displacement traveled under the uniform velocity? So here you can see uniform velocity is this part. If I highlight that part, you can see it's from starting from this point where it reaches a velocity of 15 meters per second until it starts decelerating at the beginning of 12 seconds. This is the area where the object moves with uniform velocity. So now we will calculate the uniform displacement with uniform velocity. So if I say displacement with uniform velocity, that will be equal to the length into breadth. Length is 12 minus 6, that is 6 into breadth is the height of the graph, that is 15. So here we will get the value as 90 meters. So students, when the object moves with uniform velocity, this is the area under the graph. It will be either a square or a rectangle, and the area of the rectangle, the length is this and the breadth is the height. So 6 into 15, we get the value as 90 meters. What is the deceleration during the last 3 seconds? Again here we will be calculating the gradient to find the deceleration. So as you all know, we will calculate acceleration, that is equal to the gradient that is equal to difference in the y-axis values. So here this is the final value, right? So we will have to consider this point where the value of y is 0. So we take the point, we will mark the 2 points. This is the final coordinate that we are going to take, and this is the initial coordinate we are going to use. So the final coordinate is 0 for y. So 0 minus the first coordinate here is 15. So we write 15 there, and for the x values 15 seconds and 12 seconds. 15 minus 12. If we calculate the value, it will be minus 15 divided by 3. That is equal to minus 5 meters per second square. As you all know, a negative value for acceleration will be the deceleration. So we rewrite it as deceleration equals 5 meters per second square. Then what is the displacement during the last 3 seconds? So that is again the part where the body moves with deceleration. And you can remember, students, the displacement is calculated using the area under the graph. So here again, displacement will be equal to the area under the graph. So that is the area again. If I mark it here, it is this triangle. So we will have to calculate the area of this triangle. Half into base into height. So that will be half into, the value of the base is 12 to 15. 15 minus 12 is 3. And the height is the maximum velocity that was there for the object, that is 15 meters per second. So we get the value as half into 45, that will be 22.5 meters. So we get the value as 22.5 meters. As you all know, velocity is meters per second, time is seconds. So when you multiply meters per second by second, you end up with the unit meters. That is the unit for displacement. Write down an expression in order to find the total displacement traveled by the object during the complete motion using the velocity time graph. So they want us to find the total displacement traveled by the object using the graph. Now all this time we calculated the area under the curve. We saw for acceleration and deceleration, it was triangles, and for uniform velocity, it was a rectangle. But as a whole, if we take this full graph, you can see the shape is a trapezium. The shape is a trapezium, or you can call it as a trapezoid. It is either known as a trapezium or a trapezoid. So now to find the displacement of the complete journey, we will have to find the area under the trapezium. And the area of a trapezium is calculated by considering these two sides, the sides that are parallel to each other. If we take a trapezium has a short side and a long side, but the two sides are parallel to each other and it is connected like this to give the trapezium shape. So if we take this as x and y, we take the sum of the two parallel sides, divide it by 2, and then we consider the perpendicular height h. So for an area of a trapezium, we take half into sum of the parallel sides into the height. This is the equation that you will be using to calculate the area, that is the displacement of the object during the full motion. Area of a trapezium, half into sum of the parallel sides into its height. So, if we do the calculation here, the displacement will be equal to half, and the sum of the two parallel sides, you can see here the longer side that has been denoted as y is 15. The short side of the trapezium, that is from 6 to 12. So, the length of the short side is 6 meters. And we multiply by the perpendicular height, that is this height, the maximum velocity obtained by the object. So, when I do the calculation, half into 15 plus 6, 21 into 15, we get the value as 157.5 meters. Children, here of course you cannot simplify this equation. You will have to multiply 21 by 15 and then you will have to divide it by 2 to end up with this value. That is the total displacement of this object. So students, by now you would have really understood how we use different graphs. The displacement time graph and this the velocity time graph, and then to calculate different quantities using the graph. Now we will discuss the next topic, that is gravitational acceleration. You all are familiar with this gravitational acceleration. The force that acts on a falling body is the gravitational force exerted by the earth. Now say if I take this pen, I drop it down, it comes down. Any object that you drop from a certain height or a fruit falling from a tree coming off the tree always comes down. The reason is this gravitational force. The earth always exerts a gravitational force on all the objects. So, therefore, the objects come towards the earth. And this force generates an acceleration. The acceleration caused by the Earth's gravitational attraction is known as the gravitational acceleration. So, the Earth exerts a gravitational force which causes an acceleration, that is called the gravitational acceleration. This has a symbol, simple g. We use simple g as the symbol for gravitational acceleration. So, the gravitational acceleration g, from this you can see the average value for the gravitational acceleration at sea level. Now, normally you all know for any geography height measurement purposes, we take the sea level as the basic level. So, at sea level, the value of the gravitational acceleration is 9.8 meters per second square. This is a value that you have to remember, students. Always remember, gravitational acceleration has a value of 9.8 meters per second squared, the same unit as normal acceleration. But for convenience of calculation, we can take different values or the rounded value that will be 10 meters per second squared. Before we go to that, we will see how an object moves with gravitational acceleration. So, as an example, we look at an object. Suppose that a body falling vertically down after starting from rest. So, initially it is at rest at a certain height and the object is dropped. It takes 4 seconds to reach the ground. It falls down and reaches the ground after 4 seconds. Its velocity change during each second can be stated as follows. So, as you all know, initially the object is at rest. The body is at rest. So, therefore, the velocity of the body will be 0 because it is at rest. As it is dropped down, it starts moving downwards with an acceleration, that is gravitational acceleration. The value is 9.8 meters per second squared. So, when we say gravitational acceleration is 9.8 meters per second squared, every second the velocity increases by 9.8 meters per second. So, at the end of the first second, the object would have reached a velocity of 9.8 meters per second. Then at the end of 2 seconds, the velocity at the end of 2 seconds, again it will increase by another 9.8 meters per second. If we write that value, that will be 19.6 meters per second. 9.8 and 9.8, 19.6 meters per second. Again the next second, that is the third second, it will increase by another 9.8 meters per second. 29.4 meters per second. If you add 9.8 and 9.8, you will get the value 19.6 meters per second. 19.6 plus 9.8, you will get 29.4 meters per second. And another 4 seconds, it reached the ground at the end of 4 seconds. So, the last second, that is the end of 4 seconds, the velocity would have increased by another 9.8 meters per second. So, we will have 39.2 meters per second. So, as you can see, the body fell from rest and moved due to gravitational acceleration, which is equal to 9.8 meters per second. Therefore, at each second time interval, the velocity increased like this. So, there is a height that the body fell from. Said it was at rest at a certain height. So, they want us to calculate the height that the body fell down during 4 seconds. Now, if you look at this motion, the body is moving under uniform acceleration. So, if it is a uniform acceleration, we calculate the displacement using an equation where we use mean velocity into time. So, here the height from which the object fell, That is the displacement. It was on top, then it came down. And it fell down and reached the ground. So this height is the displacement of the body. So if we are to find this height, we find the displacement by multiplying the mean velocity by time. So here straight away I will do the calculation. Height that the body fell during 4 seconds is the displacement. That is equal to mean velocity into time. So I will do the calculation by substituting the value. So we need to calculate the displacement by multiplying mean velocity into time. So here to calculate the mean velocity, initial velocity is 0, final velocity is 39.2 meters per second. You add them together and divide by 2 to calculate the mean velocity. To multiply by time, you can see it's 4 seconds. So we have to multiply this by 4. If we simplify it, it becomes 39.2 divided by 2 into 4. Can simplify 2 and 4. So the value will be, when we simplify 2 and 4 and then multiply 2 into 39.2, we will get the value as 78.4 meters. So that is the height from which the object falls down. Now we will see how we can represent this using a graph. The graph is given to you. It is the velocity time graph. Now you all are very familiar with this graph. You can see time is in seconds, velocity is meters per second, and as you can see, I said although the value of gravitational acceleration is 9.8 meters per second, the real value is 9.8 meters per second squared, but for convenience, we take the value as 10 meters per second squared. So that is for calculations. If we consider it as 10 meters per second squared, for each second, the velocity will increase by 10 meters per second squared. But here, the correct value is given to you. You can see up to this point, 30. If we look at the value again, it is 39.2 meters per second squared. So at this point, the value will be 39.2 meter per second. That is the maximum velocity of the object when it reaches the ground. Here you can see initially this point the object is at a certain height, and this point with the maximum velocity it falls to the ground. Now we will see how we can find the height from which the object fell using the graph. Remember students, we have done this calculation before. This is a velocity time graph. How do we find the displacement? Yes, we calculate the area under the curve of the velocity time graph. So to find the height, we find the area of the triangle that has been shaded to you. Area of the triangle, that is the area under the curve. So here you can see the triangle is this. area is half into base into height. So half, the base is the time, that is 4 seconds. The height is the maximum velocity, that is 39.2 meters per second. So if we substitute that value here, you can see half and 4, you can simplify that to the second and per second gets cancelled off. So if you multiply 2 into 39.2, we get the value as 78.4 meters. This is the height from which the object fell down. So as you can see, we did the same calculation before. I'll go back to that slide. Here also we have got the same value, 78.4 meters. So if you are not using a graph, you can use this equation to calculate the displacement. But if we have the graph, then we use this equation where we calculate the area of the triangle, that is the area under the curve of a velocity time graph. I hope you all understood up to this point. With this in mind, we will do a few examples. The first example is, consider a body projected upwards with a velocity of 20 meters per second. This is slightly different. A body is projected upwards. That means we throw something upwards with a velocity of 20 meters per second. So initially we throw the object up. It has an initial velocity that is 20 meters per second. The change in the velocity with time is shown in the table below. Now you can see the body was projected upwards. It's trying to go up, but the gravity is pulling the object down. Therefore, due to the gravitational force, the object will decelerate. That is why the velocity decreases with time. Initially, the velocity was 20 meters per second. We take the gravitational acceleration as 10 meters per second squared. Therefore, when it is pulling the object down, it acts as a deceleration. So, the deceleration is 10 meters per second squared. Therefore, at the end of 1 second, the velocity becomes 10, and at the end of 2 seconds, the velocity has become 0. So, therefore, the object will go up, the velocity will decrease, and it will reach a maximum height. And then, if we look at the motion thereafter, the object will fall down. But here we will only look at the movement of object from the point it's projected upwards until it reaches the maximum height where the velocity becomes 0. So if I summarize that, the object will reach a maximum height velocity will become 0. So those are the 2 points that you need to remember. If we plot this data in a graph, again we have to label the axis. The x-axis will be time. and the y-axis is velocity. V meters per second. Then we mark the values. There are only 2 seconds. So I can take this as 1, 2 seconds, and the velocity goes from, it actually decreases from 20, then it becomes 10, and finally it becomes 0. So if I mark the values, initially the velocity is 20 meters per second when it is projected upwards. At the end of 1 second, the velocity becomes 10 meters per second. And finally, at the end of 2 seconds, the velocity is 0 meters per second. If we plot the graph starting from this point, see that starting from 20 meters per second value, the graph is a straight line going down, so it shows deceleration. The graph has a negative slope, therefore it is a deceleration. That is, when it reaches the maximum height, the velocity becomes 0. The next example, an object was projected vertically upward at a velocity of 30 meters per second. Prepare a velocity time data table. We have to prepare the data table indicating the variation of the velocity with time for the movement of the object from the time it was projected vertically upwards until it reaches the maximum height. So again, we are throwing an object, projecting an object upwards. So it has an initial velocity. It will go up, but the velocity will decrease because the gravitational acceleration is acting downwards. And finally, when it reaches the maximum height, the velocity will be 0. So for a table, you need to have a table like this, and the two data on top, you will have time in seconds, and here we will have velocity in meters per second. So initially, when we take the starting point, we take the time as 0 seconds, and the body was projected with a velocity of 30 meters per second. So here the value will be 30 meters per second. At the end of 1 second, we take g as 10 meters per second squared for convenience of calculation. So this is going to be a deceleration. So at the end of 1 second, the velocity will become 20 meters per second. After 2 seconds, at the end of the second second, the velocity will decrease by 10. So it will become 10 meters per second. And finally, at the end of 3 seconds, the velocity will become 0. So as you can see, we projected the object upwards with a velocity of 30 meters per second. It reached its maximum height with velocity 0 at the end of 3 seconds. This is the data table for the movement of this object. Now we will see how we can plot this in a graph. So we have the data table that we created in the previous question. Now we will have to sketch a velocity time graph to describe the motion. So as you all know, always for a graph you have to label the axis first. X-axis becomes time, t seconds, and it is a velocity time graph. So y-axis velocity v meter per second, that is the unit, and then we need to mark the points. Time 0 to 3 seconds. So 1, 2, 3 seconds, and the velocity starts from 30 and reaches 0. So if I mark the 30 here, 10, 20 and 30 meters per second. So the 2 points will be, or the points of the graph will be initially projected with 30 meters per second. At the end of 1 second, it becomes 20 meters per second. At the end of 2 seconds, it's 10 meters per second. And finally, at the end of 3 seconds, it is 0 velocity. And if I connect all the coordinates, you will get a straight line starting from the maximum velocity which the object was projected upwards, that is 30 meters per second, coming down to 0 meters per second at the end of 3 seconds. Find the maximum height reached by the object. Take g as 10 meters per second for convenience of the calculation. So here we can do the calculation in 2 ways. You already know that by now. We can either do a direct calculation because this is a movement under uniform acceleration. The body underwent uniform acceleration. So we can find the mean velocity of the motion and then calculate the displacement. That will be the maximum height reached by the object. So here, if I use that method, maximum height is the displacement that is equal to mean velocity into time. So here the initial velocity was 30 meters per second, final velocity 0 divided by 2 gives you the mean velocity, and the time taken from the graph, you know, it's 3 seconds. So if we calculate 30 divided by 2 into 3, that will be equal to 90 divided by 2, that is 45 meters. That is the displacement, because here mean velocity meters per second, time second. So when you multiply second by per second, that gets cancelled off and you get the unit as meters. The same calculation, since we have the graph, as you all know, we have done before, the displacement can be calculated using the area under the graph, which is the area of the triangle. So if we use the graph to calculate the maximum height, it will be the area under this graph. So that will be equal to half into base into height. Half, the value of the base is 3 seconds and the height is the initial velocity 30 meters per second. if we simplify this again, it is 90 divided by 2. 90 divided by 2. As you can see here, the second and per second will get cancelled off, and so when we divide 90 by 2, we get the value as 45 meters. The same value as we calculated here. So by now, students, it is clear to you that you can do the calculations of finding the displacement using the velocity and the time for an object moving with uniform acceleration. The same calculation can be done from the graph by calculating the area under the graph. So students, I hope you all understood all the topics that we have discussed so far under this lesson. Now we will look at a summary of what we have discussed so far. The summary: the distance traversed by a body to move from a certain point to another point depends on the path taken. That is what we call as the distance, and it is a scalar quantity, but its displacement depends only on the initial and final points. So here you know the difference between distance and displacement. Distance has a magnitude only, therefore it is a scalar quantity. Displacement is a vector quantity. The magnitude of the displacement is the straight line distance between the initial and the final points. So when there are 2 points, the straight line gives you the shortest distance. Its direction is the direction of the straight line segment drawn from the initial to the final point. Again, try to remember, children, when they give you a direction and specify the movement from, say, north to south or west to east, then in your answer, when you write the displacement, you specify that particular direction. But if they say starting from point A and ending at point C, then in your answer with the magnitude, you specify the direction as from A to C. So depending on how they give you the direction, you will have to include that in your answer. The rate of change of distance or the distance traversed in a unit time is known as the speed of an object, and speed is a scalar quantity. So remember the terms: distance, displacement, scalar quantity, vector quantity, speed. You should know the equations relevant to these and the definitions. Here the definitions are given to you. Speed is distance divided by time. The rate of change of displacement is known as the velocity. That is the next quantity, and it is a vector quantity. Velocity, the equation is displacement over time. The rate of change of velocity is known as the acceleration. A negative acceleration is known as a deceleration. So always when you do the calculation, write the equation for acceleration. You say acceleration, velocity, change of velocity divided by time. And when you get the negative value, you rewrite it and write it as deceleration equals a positive value. So here the equation is acceleration equals change of velocity over time. Okay students, this brings us to the end of the lesson. So I hope you all understood all the theory and the content including the graphs, and with those in mind we will practice some questions. These questions will include the questions from your textbook as well as some additional questions.